Well, here we go. Exercise number 30 here. We have an algebra problem. We're given a triangle and a bunch of different expressions, algebraic expressions for the various angles. So let's first draw a picture. That's what I would do. Now, when I've color-coded it to make it easier to talk about the red, green, blues angles, and I don't know what it looks like. It could look like this. It could be a right angle there. It can be obtuse. So we don't know. I just drew this so we have something to look at. That's why we can't assume things from our diagrams and our proofs. So let's just start with this, and then we'll figure out what she really looks like. So now, going back to the very beginning of the chapter, Theorem 4.1, which tells us the triangle sum theorem, really. Sum of the interior angles, 180. So those three expressions have to add up to 180. Very conveniently, we have the same variable, x. So we know this is going to work. Well, we can simplify them. We'll combine all the terms. And then, let's see, we'll add the 28 to both sides and divide. I shouldn't have to tell you how to do algebra. Come on, you're in geometry. So let's look at this. Let's do some substitution here. Now this is the geometry part, it's the thinking part. So I'll just substitute the 16 into these three expressions. And, well, what do I get? Oops, covering over there. I'm going to get 66 for angle D, 66 for angle E, and 48 for angle F. Well, if I drew it to scale, I would actually get this. And you see I've got a pair of congruent angles. Angles with the same measure are congruent. And that reminds me of something in Theorem 4.8, that congruent base angles means opposite sides are congruent. So I would say that this triangle is isosceles. Number 31. This is a classic exercise that, well, your teacher should have it on your test. You've got this triangle ABC. And we see the first statement, D is the midpoint of AC. So let's put D in there. That's the midpoint of AC. And then we're going to draw BD, and that's perpendicular. I guess I would call that the altitude of the triangle. Well, that's next chapter, but you already know that. And now let's see. I know BD is congruent to itself by the reflexive property, so you should see a pair of triangles right here. You see they're reflections of each other, and they would be congruent by side angle side. Once they're congruent, corresponding parts of congruent triangles, or bicongruent triangles, we would reason that all their corresponding parts, in this case, AB and CB, are congruent. Therefore, the triangle is isosceles. So let's just write that down like that.